All right, well, thank you for that introduction and welcome back after lunch. Today I'm going to talk about a use case at Nielsen where we utilized Spark and Databricks to solve a large-scale data issue in some of our newer methodology. So before I get into the exact methodology, I want to talk a little bit about our company, Nielsen. It's founded in 1923, so probably among all the companies here at Spark Summit Europe, probably one of the oldest, if not the oldest company. It's organized into two pillars, both buy and watch, and Jarrett talked a little bit this morning about the two pillars of Nielsen. The first is buy, or buy side as we call it. That's focused mostly on market research, and actually Arthur Nielsen coined the term market share way back when. But today I'm going to be focused on the watch side of the business. And if you're familiar with Nielsen at all, you probably know of Nielsen TV ratings. That's what we're most known for. And in particular, if you kind of expand that out, audience measurement. But Nielsen's not just TV ratings, not just TV measurement. We also do radio and also digital, which includes like PC, mobile, over-the-top devices like Roku's and Apple TVs, and also digital TV and digital radio. So we have a pretty broad palette for digital measurement that nicely complements, I think, excuse me, nicely complements our TV measurement as well. So one thing about digital measurement, digital audience measurement, it's growing. Depending on which source you look at and which country you look at, digital ad spending is now meeting or exceeding the TV ad spend. So Nielsen's been known for TV for a long time, but that digital component has been growing and growing rapidly. So fortunately, I work in the digital measurement portion, and in particular on a product called digital ad ratings. And it's exactly what it sounds like. It's measurement of ad ratings on computer, mobile, and over-the-top devices. It's comparable to TV ratings in the fact that we produce an audience measurement. Basically, who's behind the screen. You know, for TV, it's who's behind the TV screen. For digital, it's who's behind the tablet, laptop, PC, and now extending to the over-the-top devices, like I said before, like Roku. So again, it's who's behind the screen. The main kind of measurement that we provide there is on what we call advertising campaigns. So an advertising campaign, you're familiar with this, like if a restaurant produces a new menu item that has maybe a new ingredient, they want to tell you about it, right? They're going to tell you about it for a set amount of time, and then after that, it's kind of part of their menu, and it's no longer new, so that advertising campaign ends. The primary focus of these advertising campaigns is focus on age and gender breaks. So, for example, an advertiser is interested in how many digital ads were served to a target demographic, such as, let's say, adults 25 to 49. And then we produce a rating for these ad campaigns, and then the advertisers actually trade on what we call an on-target delivery or on-target percent, and that's our main key metric. So if an advertiser targeted adults 25 to 49, and let's say 80% of their ad impressions were served to that target demographic, their on-target percent would be 80%, which is a pretty good number. Digital ad ratings is a global product. We're in 25 countries right now, and that number will continue to grow in the future. So how does DAR or DAR work? So first, the end user is served an ad impression, again, either on a mobile or computer device, or even on an over-the-top device. That ad impression then sends a ping and gets picked up by a third-party data provider. And that third-party data provider provides some demographic information to Nielsen, which we then use. I consider this part here big data. Jarrett talked about a little bit about digital early this morning, and there's over 1 trillion ad impressions served each year. So we're talking some really large data here. The next thing we do is, our clients can very interested in accuracy. They want accurate measurement. And the thing with big data, and especially using demographics provided by a third-party data provider, it's not 100% accurate every time. So that's where Nielsen comes in. We apply our methodology to actually adjust this third-party big data for different biases, which I'll go into in detail here in a second. And that's going to be the main focus of today's presentation. After all this, after we add impressions served, we attach third-party demographics to it, we adjust those demographics, then we're ready to report out to a client, and we have overnight reporting of unique audience, like the unique number of people that saw it, the ad impressions, which is just how many times an ad was served, and then that on-target fraction. So a little bit about the Nielsen adjustments. So big data is not perfect. It needs bias correction in order to be accurate. And that's where the value of Nielsen's high-quality panels really shines, because we can actually use our panels to create have a truth set. We go out and recruit households and have verified demographics for people in person. So that serves as our truth set, and that can sometimes differ than what their digital footprint says. So we have three main sources of bias that we correct for. The first is for misrepresentation. So that's people that may self-report an age that's different than what their actual age is. The second is misattribution or sharing adjustment, and that's where the person that the third-party data provider sees is actually different than the actual person viewing the ad. So we call this a sharing correction. So like in a case like if me and my wife share a device, she may be logged in and the third-party data provider picks up on her demographic, but I'm actually the one viewing the ad. That's a case where we have misattribution or sharing that we correct for as part of Nielsen. The third source of bias is non-coverage. So in some cases, not everybody's covered by a third-party data provider, so we adjust for that as well. So I'm going to touch on the misattribution or sharing and the non-coverage adjustments as part of today's talk. And really these Nielsen adjustments are an active area of research and development and what I spend a lot of my time doing. So a little bit more about our panel data sources. We have metered home PC behavior. We also, for mobile, we use surveys. And it's a representative sample of US homes. We have panels in other countries as well. And it's something I kind of consider medium data. It's not really large or big data. It's not really small data. It really, there's a large volume of it, but it doesn't really come in all that fast. So it's kind of low velocity. So to me, it's kind of a medium data. And then that production impression data, those impressions that have third-party data provider information attached to it, that's really our big data. That's our big data source. So if I call it, I'm talking about a production data, that's our big data that needs adjustment. So this kind of led us to the question is, what's the best way to create Nielsen adjustments and then test them in a production environment? So we have this medium data from our panel. It's pretty easy pretty straightforward to manage and test, but then we get to our production data, and that's a whole different animal. So this really forms the foundation for our Nielsen's Databricks and Spark use case. So a little background on our business case. We recently developed some new DAR adjustment methodologies, again, for that misattribution and non-coverage. And we tested them at small scale and found that a couple of these new methodologies are actually an enhancement over what we currently have in production. However, we have a business requirement that when we're launching a new methodology or an enhancement to an existing methodology, we really need to test it and test it heavily, because we need to understand the impacts of these new methodologies or methodology enhancements. Need to understand the impact to our clients. We have a very broad range of clients that serve ads and do targeting in different ways. So we really need to test a lot of our production data to see how it behaves with these new methodologies. Another benefit of that in testing just a large number of advertising campaigns is that we could identify edge or corner cases where that methodology breaks down. And really that's important for us in providing a quality product for our clients, because we don't want these methodologies breaking down and our clients getting that, those data that are of lower quality. We want to be out ahead of that. So the more we test it now, the better, and the sooner we can get ahead of those issues. So some of the small scale testing I mentioned to begin with, that we originally did was about 20 advertising campaigns, just a small subset. And then our large scale testing was about 4,000 advertising campaigns. So the idea is, okay, we tested these new methodologies in a small scale. How do we increase that by now 200 times? That's where Databricks comes in. Databricks and the interface to Spark that it provides. So one of the main things that we used Databricks for is for cluster management. I'm not going to talk too much about that. I wasn't really involved in that part. But the second bullet here I'm going to speak at length about is one benefit of Databricks is that it really provides a friendly interface to Spark for our data scientists. So at Nielsen, we have a very, our data scientists come from a lot of really broad background. So we have data scientists are methodology experts, subject matter experts, but they're not all coding experts. So a lot of them don't have experience with Spark or even distributed environments. So having a nice friendly tool to use Spark was really advantageous, and got more of our data scientists that serve a bunch of our different digital products, got them using Spark and analyzing more and more data. Some of the benefits that the Databricks notebooks provided for us is that we could use multiple programming languages. So we have some new graduates that we've hired that are coming out of college with R programming experience, but maybe not Python. So they can start using Databricks and Spark using that R interface, whereas some of us have been trained in Python. We're familiar with that. But then we could also use some of our existing SQL scripts to perform parts of the methodology that we didn't adjust with these new methodologies. So my favorite part of the Databricks platform is that, again, we can use these multiple programming languages, but then we have access to all these other algorithms that aren't available in just like vanilla SQL. And in particular, one of the adjustments that we tested as part of this is used singular value decomposition as one part of that basically custom algorithm that we built. And that singular value decomposition is not available in SQL. So we're able to actually go in, create some adjustment factors using Python, using singular value decomposition there, and then sending that output of those calculations to a SQL script that actually applied the adjustments. Another thing we're able to do is actually link to our production databases. So we can actually apply these new adjustments, this new methodology to production level data. And then of course our current methodology is in that production database as well. So now we have our A/B testing, all of our data right there, and can do A/B testing and assess the impacts to our clients. So as I mentioned, Nielsen's been around since 1923. So as Jarrett talked about this morning, we're in this period of transition to new technologies. So some of our panel data in particular still lives in kind of some older systems, some Oracle and Netezza systems, and we do some transfers between those, and actually that gives us our aggregated panel data. We then have our aggregated production data in a data lake. And really what kind of one really cool thing about Databricks and working in the cloud is we put all these data points together and can run all of our analysis all in one place. So we really combined our medium data from our panel and then our large data from our production data, or production data sources, put them all together, and then run all our analysis basically in one notebook or in one script. So this is really beneficial to actually making this methodology work. So I'll show you some real simple pseudocode. I can't show all the details of this due to some intellectual property reasons, but I can kind of give you the gist of what we did here. So we just so I mentioned we did some small scale testing. We did some small scale testing in Python, and we were able to actually port over that custom algorithm into Databricks. Pretty simple cut and paste. And really what we have here is just a function, says create adjustment factors, and we're taking that medium or small data from our panel and using that as an input. And then we can create our adjustment factors using basically our algorithm of choice. In this case, we're using singular value decomposition, amongst several other things. But yeah, again, the ability to develop some small piece of code kind of locally, maybe in our spare time, and develop some new methodologies, test them at small scale, and then not have to reinvent the wheel to go test this at a larger scale is really beneficial for us, and I'll talk about that in a second. One thing that we did is our adjustment factor is actually organized in a matrix. And for a reason I'll talk about here in a second, let's say we have a 10 by 10 matrix, and that's 100 cells. One thing we did is we actually used this flatten command, and that actually takes the matrix and turns it from a square matrix into like this vertical vectorized matrix. So instead of a 10 by 10 matrix, now we have a 100 by 1 vector. And then that forms the basis for our adjustment factors. So then now we want to apply this to our production data. And again, here's some pseudocode, some really simple stuff. But what we want to do is matrix multiplication between that adjustment factor matrix and then our vector of provider data needing correction. So here we just have a simple dot product multiplication or matrix multiplication written in SQL. Again, we're joining rows in the first matrix, so the columns in the second, multiplying those and then summing those, and that gives us our final end product matrix. And we found that this worked. This really improved our runtime. Mainly, we could use like the dot matrix multiplication in one of the different Python packages, but by setting up our matrix multiplication to run in SQL, then we can take advantage of the catalyst to make this actual application of these factors run a lot faster. So some performance gains. So in testing these 4,000 advertising campaigns, we figured it would take us, basically using our current infrastructure, about 36 hours just running that with our standalone Python script. But using this kind of hybrid method between Python and SQL in that Databricks notebook and again, taking advantage of Spark, took us about 1.5 hours runtime. And also, the ability to access clusters. Jared talked about earlier today where it was a long lead time if we wanted our own computing environment where when we needed to run this, I just walk about 10 feet down to Jared's desk, ask him to spin up a cluster for us, and 10 minutes later we're off and running. So yeah, definitely some runtime performance gains. And I'll skip to the third bullet here. So when you have that short of runtime, then you can go back and make any revisions to the methodology. So if I maybe run some analysis, show my boss, hey, here's the numbers we're seeing. She may come back and say, this looks good, but can you try it this way? So we may go back and tweak some parameters and rerun the data, and then I could show it to her again. Whereas, before, if we wanted to do that, I have to make those tweaks, go have fun over the weekend or something, and come back, and hopefully it ran over the weekend. And then if there's any additional tweaks, wait a couple days, and then have my results ready. So Jared talked about a lot of the iterative approach to data science at Nielsen and developing methodologies, and this really sped things up and really helped us identify some shortcomings in our methodology. So we found one of our candidate, actually non-coverage methodologies, seemed like it performed well in small scale testing, but then we tested it at large scale and found a high percentage of cases where it was kind of performing suboptimal, producing maybe some illogical values. And we would have never found this without the large-scale testing. And actually, the frequency of that of this edge case popping up was actually outside of what kind of our tolerance was. So we chose a different methodology over that one based on this large-scale testing. Some other benefits to using Spark and through this Databricks platform is reduced time from idea to development. So as I mentioned, we're able to really iterate through and kind of try some different tweaks in our methodology. And in the long run, that extended testing, that 4,000 campaigns testing, was definitely like something that had to be done if we wanted this methodology to go in. The fact we're able to tweak it, rerun it, and kind of put the finishing touches on it in a very short amount of time means it's going to be available to our clients sooner. And I mentioned earlier on, like these methodologies were enhancements to our current methodology. So basically, we're saying like we're going to have enhancements or benefits to our clients available sooner. So that's a win-win in all cases. Another thing too is we have enhanced support investigation once deployed. So if a client comes back and says, hey, why does my data look a certain way? We're able to actually go in and run the methodology end to end. If we have a client with a large amount of data, we're able to run their full data set end to end, and we can address those client queries sooner rather than later. Some other benefits is enhanced collaboration, especially with our application development teams. So before, we just basically develop a methodology, put it on an Excel sheet, write up a Word document, hand it over the fence to our application development teams, and then they would code it. Now, with our renewed focus on best coding practices and really getting our data scientists to think about optimization and working in these distributed environments, we're have a really good piece of code that we may use for R&D, but we can actually hand that to our application development teams. They may not use any of it. They may use all of it, may not use any of it, but at least that provides some documentation, and it's much cleaner to show the different steps we take. So it's enhanced collaboration with our application development teams, also our international teams. So we have these new methodologies. We can drop in different countries' data and test it. We also can use the commenting feature in the Databricks notebook to say, hey, Australia, you want to use this parameter here and this other parameter here, and then they can rerun that, and then we can actually share results and look at the results together. And lastly, these new methodologies are actually being tested in other products. So one really nice thing about this this notebook is, it's code and languages that are familiar to a lot of our data scientists, and it's pretty easy to port that over to a different product. And really, I can train a couple different subject matter experts from some different products, can train them in 2-3 hours on some of this, and actually have them running new methodologies on large pieces of data in a very short amount of time. And of course, that enhances our skill sets as data scientists. Again, we're thinking about distributed computing environments. What else is next? What else can we do with the methodology to enhance it now that we have some of these tools available to us to really process a large amount of data in a very short amount of time? So just to summarize, at the end of the day, this Spark Databricks combination really allowed us to solve this business use case. Again, that large-scale testing was required, but it would have been a very laborious effort if we tried to use it kind of using some of our older tools. And Databricks came along at the right time to where we could actually test this and do some adjustments on the methodology and really solve this business use case. And in the end, the reduced R&D timeline plus this extensive testing will allow this enhanced methodology to be available to our clients sooner. So continue producing high quality data for our clients. So with that, thanks for your attention. I want to especially thank Mala Sivarajan and Nielsen with their help on this project, and I'll be happy to take any questions you might have.
If there are any questions, feel free to step up to the mics on the left and the right. All right. Well, in that case, we'll end early. Thank you, Matt.
All right, thanks.
Thank you, Nielsen team.